Namaskar, my dear friends. So we had seen the device overview of PIC18F 47Q10, right? So our target device was PIC18F 47Q10, and we will be seeing 40-pin PDIP package. So we had seen the device overview, its features and its capabilities, and we had also seen the family types, and our concentration was, as I told you, PIC18F 47Q10, and we will be seeing package PDIP for our application design. Okay, so this will be our PDIP package application. Before that, what we can see is we can see what are the different family pins available, and then we will see the 40 pin as well. So if you see in pin description, we have a PIC18F 47Q10 and 27Q10. So some of them are having like a 28 pin SPDIP, SOIC and SSOP, right? So in this you can see this is the way pins are allocated. Okay, so this is in my PDIP package or SSOP package or SOIC package for 28 pins. All right, and you can see it has only one power pin, that is VSS is ground and VDD is power pin. I think it is having two, one more VSS is here. Then if you go to 28 pin QFN package or VQFN package for better thermal capabilities, because SSOP package will be less thermally stable. However, if you want very high thermal capabilities, then you can go ahead with QFN package or VQFN package for 28 pin. So for a small application which require less number of pins, you can go ahead with 28 pin packages. But our aim is to develop a application with 40 pin package. So if you see 40 pin package, it has been arranged like this. And when one best thing about like PIC18F 47Q10 is it is directly pin to pin compatible. Okay, with your PIC16F 877A that I had told you in the beginning in the previous videos. Then PIC16F 18877. Sorry, it is 16F, not 18. So these two we have already seen in our previous videos with 40 pin PDIP package only. So if you see this new device PIC18F 47Q10 is pin to pin compatible with these two previous ones. Okay. So if you want to upgrade your device or if you want to upgrade your unit with no obsolescence issues in future, let's say maybe 10 years or 20 years from now, then you can replace this one with your this one. Okay, this PIC18F. PIC18F 47Q10 is also available with a 40 pin QFN package for better thermal capabilities. But the pins are inside, as you can see, it is QFN package. However, if you want to go ahead with 44 pin package, it has TQFN like packaging. So TQFN packaging, the pins will be outward. Okay. So what we will do is our aim is to look into 40 pin PD package. So instead of seeing this directly, what we will do is we will trying to go to pin allocation table. Like let's say this is RE3. So RE3 has some other capabilities or RH0 has some other capabilities, like that we will try to see. Okay. So let us directly move to a pin allocation table. Okay, so in pin allocation table, our aim is to go ahead with 40 pin PD package. So we will see this is my 40 pin PD package. So our aim is to see this particular column. Okay, we do not concentrate on 40 pin QFN and 44 pin TQFP. If you are considering those devices, then you have to see RH0 will be pin number 19, but PD package RH0 will be pin number 2. Okay, just now we had seen. If you want me to show you, let's say PD package pin number 2 is RH0, so pin number 2 is RH0. Okay, whereas RH0 in TQFP package 44 pin package is pin number 19. So pin number 19, if you see, this is 44 pin package. So pin number 19 is here, RH0. Got it? So this is how it is mapped. All right. So considering the fact that RS0 is having other functionalities, like yes, A to D converter is there, ANS0, then comparator is there, that is C1 in 0 and C2 in 0. So basically, like comparator negative input for channel 1 as well as channel 2. Then it has the capability of interrupt, like IOC interrupt on change. Okay, so this is how, and it is pull up. So yes, internally it is pull up also. Same way for RA1, it has almost same capability as RA0, that is analog to digital converter, comparator input, and then it has like interrupt of change and internal pull up. Coming to the fact that RA0, RA2 is having the capability of ADC as well as DAC out, DAC 1, out 1. Okay, so it has the capability of DAC. So you have to just make a note that my RA2 has the capability of DAC output. Okay, the rest others are same. And it has Vref minus as well. Like if you want to give the reference voltage for analog outputs or inputs, like external reference, then you can see Vref minus at this particular pin. RA3 is having Vref plus also, and as well as analog to digital converter. So almost all the pins are having ADC channel capabilities. RA4 is having, no sorry, RA3 is having capabilities of comparator input positive. Okay, so these were negative inputs and this is positive input. Okay, similarly interrupt on change capability is also there, and MDCA RLB is also there. Okay, so I have already explained in one of the video like what are the different uh, terminologies for all these particular names. Okay, for RS0, if you see, it has ADC and it has timer 0 clock input. So if you want to give like timer for external clock, then you can directly put it into this. So very high end applications you will be requiring those things. However, I'm just explaining for the sake. Anyway, this is not required. All right. So if you see, most of the pins are like by default IO pins, and those IO pins you will be directly able to assign those, right? So hope you are understanding this particular understanding, like how pins are allocated. Let us quickly move to some other pins. So I'll try to point out which are the pins that will be like peculiar. So RA5 is almost same functionality. Then RA6 you are having OC2. So here only you will be connecting your high speed oscillator. Okay, and RS7. So RS6 and RS7 will be utilized for our external oscillators. So you can see OSC1 and OSC2, or if you want, you can give externally one clock input at this clock in. Okay, and clock out, if you want to take, this will be the clock out. Understood? So if you want to give a clock input from your external source, then this will be the pin that will be utilized. Or otherwise, you can utilize your internal clock also. That is not a problem. Otherwise, you can use one external clock source, that will be your crystal oscillator or maybe some other source that is being used. Then coming to the fact of RB0, so RB0 has the capability of like zero cross detection, and then it has interrupt capabilities also. Then it has SS2, that is slave select or client select also we tell for SPI. So for SPI you will be having client select or slave select pins. Similar to that, RB1 is having SCK or SCL. So SCK is for SPI clock and SCL is for I2C clock. Okay, and RB3 is having SDI. So SDI is data input for SPI, and SDA is for data input output for I2C. Okay, so this will for I2C data input, and this will be for data input output, and this will be for SPI data input. Okay. For data output, there are so many peripheral pins that we will be seeing later. Rest other pins are almost same. We'll talk about let's say RB6. So RB6 is having the capability of CK, that is clock output. So for UART you can have a clock over here, and as well as ICSP clock and ICSP data. So basically RB6 and RB7 will be used for our programming purpose, which will be having in circuit serial programming clock input and in circuit serial programming data input output. Okay, So these two pins will be used for our programming purpose. So we will not, like interfere with any other pins for programming. This is my RC0, which is having, general GPIO's capability, as well as uh, this is having T1 CKI and T3 CKI, that is timer 1 and timer 3 clock input if you want to give from externally. Okay, and it has the capability of SOSCO, that is like low oscillator clock output. So low oscillator, that is 32.768 kilohertz for your RTC applications. So for that you can take output at this particular place, or you can see together like RC0 and RC1 is having SOSCO and SOSCI. So basically these two pins will be used for connecting your crystal oscillator with 32.768 kilohertz, and it will be having the capability of giving you the output for low frequency oscillator. Or otherwise, if you want to give externally, you can give externally one 32.76 kilohertz signal, and you will be getting your output at this particular pin. Got it? The rest other pins are almost same, RC2 and RC3, everything. Coming to other pins, you can see RC3 is having capability of SCK, that is SPI clock 1, and SCL, that is I2C clock. Similar to that, SDI is for SPI data input, and SDA is for I2C data input output. Got it? One more pin I'll tell you, RC7. You can see RC7 is having RX pin, so that is UART receive. Okay, so UART receive pin. Okay, you might have seen that rest other pins are almost like RD0 to RD7 is having GPIO capabilities as well as ADCs, and if nothing, none of the pins are like available for this particular set, so they are basically used for your parallel slave port purpose or data communication purpose. Okay, so if you want to send data to, let's say, LCD or some other like peripherals with your 8-bit data communication, then RD0 to RD7 I will be using for your data communication interface. Okay, similar to that, RE port, like port number 5th is A, B, C, D, E, E. So E is RE0 to RE3, and these are also having almost same capabilities. If you see RE3, so RE3 pin has the special functionality of VPP and MCLR. So MCLR is actually used for resetting the device. So this is used for your reset application for the particular microcontroller. And now VSS is my ground pin, and VDD is my power supply pin for the microcontroller. Now what you have not seen here is SDO, that is data output for your SPI, and TX, that is what do you say, transmission for your UART. So these pins were not available anywhere that you saw in this particular pin allocation table. So that will be coming next, which is called as before that we have VDD and VSS, one more set. So two pins are there for VDD and VSS, and last one is out. So out is the only thing that you have to understand, which is not selected to any pin. It has the capability of ADG RDA and ADG RGB. Okay, analog to digital converter internal, and it has C1 out and C2 out. So comparator output you can take up for any of these pins. So which are the ports that will be applicable for this particular functionality, out functionality, that we'll see just now. We have timer 0 also, and we have CCP, like capture, compare, PWM. CCP is capture, compare, PWM. Okay, so it has the capability of capture functional or comparator functionality or PWM functionality. It has PWM functionality also 3 and 4. So total 4 PWMs you can generate, 2 from these two and 2 from these two. Similar to that, CWG 1A, 1B, 1C and 1D, that is complementary waveform generator. So if you want to generate some waveforms, so these output pins will be able to make you capable of generating those particular waveform functionalities. Similar to that, you can see just now I told you TX pin are there, data transfer pin is there, then TX2 is there, then DT2 is there. So these are for UART, right? Similar to that, DSM functionality is also there. Just now I was telling about MSSP, that is SPI. So which was SDO and SCK and SDO2 and SCK2. So this functionality also can be mapped to your out pins. So the question is, what are these out pins? So out pins is a, like a PPS pin, peripheral pin select pins, that will be remappable. So you can see this note, okay, note 1. So this is a PPS remappable pin, or out. I will see out is note number 2. So note number 2 is all output signals shown in this row are PPS remappable. Okay, and this signal may be mapped to output onto one of the several port X. Port X means port A, B, C, D, E, any of these ports that will be like selected from the table. So that you can see pin output as described in the peripheral output selection table. So this we'll discuss just after this particular pin allocation information. So hope you guys are okay with this pin allocation table, like how pins are like mapped for different functionalities. And if you want to get information about your 40 pin package, then what is the IO and which pin is mapped, and what are the different other functionality that is associated with this particular pin. If you still have any questions regarding the understanding of particular pin, let's say we have RA2, so how it can be used as DAC out or one out, basically like digital to analog converter pins. If you have to have still understanding about it, you can put down your question in the comment box and we shall be able to answer you out. Okay, good. Now let us say we have to understand what is the this family details. So our aim is to understand this particular microcontroller completely, so that we don't miss even a single point before our design. Got it? So during the design of this particular PIC18F 27 or 47Q10, our aim is to understand what is the a difference between 27 and 47, right? So if you can see, the differences basically are in program flash memory or data SRAM or data EEPROM or analog to digital channels, number of IO ports. We have enhanced UARTs capabilities, we have input output voltage range and power consumption. So all these differences that you can see between these two particular series, that is 27 and 47. So quickly we will see the device features of PIC27, PIC18F27 and PIC18F47. So you can see program memory. If you go ahead with both the maximum range, then both of them are having almost same uh, program memory bytes. Then even program memory instructions are also same. Okay, but this will differ based on the different pin family that I told you. Just now I told you about 28 pins, or like 40 pins and 44 pins. And internally in 28 pin itself, they have different pins, like SPD package is there, or SSOP package is there, or SOIC package is there. So based on these different packages or something like that, their memory or something will be different. Okay, next other differences are, you can see we have data memory byte is also same almost. We have EEPROM, that is also 1024 bytes, that is 1 kilobyte. We have IO ports. So IO ports, you can see it has only A, B, C and E, but it has A, B, C, D, E. So it doesn't have data capability. So D is having RD0 to RD7. So that RD0 to RD7 can be used for your data communication, whereas data communication is not possible in your 27Q10. Okay, so PIC18F 27Q10 doesn't have data communication capabilities. Then CCP, that is capture compare PWM modules, it has two, and it has also two numbers. Then we have PWM's 10-bit pulse width modulator, that is also having both of them 2 2. Then we have ADCs, so 4 internal channel and 24 external are there. Here 4 internal plus 35 external is there. Okay, packages, if you see, so packages only 28 pins are available with PIC18F 27Q10. Okay, so and if you want to go ahead with 40 pin and 44 pin package, then you have the choice of only going ahead with PIC18F 47Q10. So our aim is to go ahead with 40 pin PD package. Okay, timers are both of them are having same 4 and 3. Then we have serial communication, that is 2 MSSP is there, that is basically SPI and I2C. Here also 2 MSSP is there. and UARTs are there, 2 UART here or 2 UART here also. We have enhanced complementary wave generators, both of them are having one channel. Zero cross detection is there, both of them are having same. Data signal modulator is there, both of them are having one. Then we have CLC, that is configurable logic cells, both of them are having 8. And peripheral pin select capabilities, both of them are having the capabilities of uh, pin mapping capabilities. Okay, coming to the fact that peripheral module disable, so both of them are having those capabilities as well. We have CRC, that is cyclic redundancy check, 16-bit, both of them are having. We have programmable high low voltage detection, so both of them are having. That is PIC18F47Q10 as well as PIC18F47Q10. We have programmable brownout reset, that is BOR, both of them are having, and reset and delays are having almost same. You can see POR, both of them are having almost same capabilities. We have both having MCLR pins and MCLR pins. Okay, we have instruction sets, so total 75 instruction sets are there, and 83 with extended instruction sets and enable is there. Here also same 75 instruction sets are there. If you talk about operating frequency ranges, both of them are having DC to 64 megahertz capabilities, and this is also having DC to 64 megahertz capabilities. Got it? Now, coming to the fact that block diagram of this particular device. So block diagram, let me take you to the data sheet, and there I'll explain you what is the block diagram. So if you see the block diagram of this particular PIC18F 27Q10, okay. PIC18F 27Q10, if you see, we have data bus, okay, so 8-bit data bus is there, and then we have port A, port B, port C, port D, and port E. Okay. Then if you see, we have DAC is there. Then we have ADC 10-bit is there. We have pod, like a PM bus or PMD. We have data signal modulator. We have enhanced complementary waveform generator. We have enhanced UARTs. We have MSSP, that is SPI and I2C are there. Then we have PWMs 3 and 4, CCP 1 and 2, that is capture compare and PWM modules. Okay, we have DAG, we have FBR, then we have brown on reset, we have NVM controller, we have timer 0, 1, 2, 3, 4, 5, 6. So total 7 timers are there. So basically 4 are like 8-bit or and 3 are 16 bits, something like that. We have 0 cross detection, we have CRC scan is there. Then if you talk about this precision band gap reference, so we have precision band gap reference. If you see internal oscillators, so OSC1, OSC2, and SOSIC, this basically high frequency input and output is there. So you can connect your oscillator here, and this is low frequency. I don't know why it is happening like this. Okay. So what I was telling you is these two pins will be used for your high frequency oscillator, and this will be used for your low frequency oscillator. Okay. So if you want to give your internal oscillator, like block is there inside, and then this is having other things are what we have in circuit debuggers. Okay. Now we have almost everything that I like wanted to tell you. These internal things, if you want, you can like look into very properly later on. So let us move to our block diagram we have done. Like block diagram actually says at one place like what are the different things that is available together. Okay. Now coming to the fact of the like basic requirement for this particular device to design this circuit. Okay. So this is our main aim. So if you see basic connection requirement, so both of the devices like PIC18F27 Q10 and 47Q10, okay, both are having like 8-bit microcontroller, and they require minimal attention. Okay, they require attention to a minimal set of device pin connections before proceeding for development. So what are those things? You must connect this VDD and VSS pin, that is your power supply pin. All VDD pin must have zero point 0.1 microfarad bypass capacitor, that I will show you in the design document, design process. Okay. Then we have ICSP clock and ICSP data pin used for in-circuit serial programming. Then we have OSCI and OSCO pin for your external oscillator source is used. Okay. We have MCLR pin with your external master clear configuration selection. Okay. And we have VREF plus and VREF minus for your external voltage reference for analog modules implementation. Okay. So this is the basic requirements that you have to look into before proceeding for development. So how it is done? So how it is done is basically, if you see, this is the PIC microcontroller. This is the VDD and VSS pin. So you have to connect one very close, like very close to these two pins. You have to connect one bypass capacitor, that is C2. And C2 value you can see it has 0.1 microfarad, 20 volts. Ceramic is recommended. So basically we try to use like 0.1 microfarad, 25 volt, which is mostly available in the market, very like very abundance. Okay, so this we will be using. This is MCLR connection, that is reset connection. So R1 and R2 is there and one capacitor is there. So you can see the values also. R1 10 kilo ohm, that will be 10 kilo ohm, and this will be used for 100 ohm to 470 ohm. So I'll use 470 ohm, and if you want you can keep reducing after checking the proper reset of the device. And C2 again 0.1 microfarad you have to use. Okay. Another process of connecting this MCLR pin is put one jumper here so that you can disconnect this so that it doesn't like interfere during the debugging process. Okay. And what about the unused pin that you will not be using? Let's say a lot of like IO pin that will be available and you don't want to use them because your application require less number of pins. Then what you can do is you can configure them as output pin and drive them low. Okay. So you configure them in software like as output and put the value as 0. Okay. Or otherwise what you can do is you can connect 1 to 10 kilo ohm resistor and connect it to ground. Okay. So basically those pins directly connect to a resistor and put it to ground, let's say 10 kilo ohm. So that will be the process of unused pin. This is best practices for your microcontroller to work very properly. Now I was talking to you about pin peripheral pin select. Okay, PPS. So in PPS what happens? Basically PPS modules connect peripheral input and output to IO device, device IO pins, and only digital signals are included in this selection. Okay, so ADCs are not capable. Okay, and all analog input output pin remain fixed to their assigned pins. So you like, let's say pin number 1 is assigned to SPI SDA pin, okay, or SDI pin. So this SDI pin can be given to another pin also, let's say pin number 10. Okay, I'm not telling you exact pins, I'm telling you just example. But if it is like assigned to ADA 0, so like analog to digital converter 0 pin, so ADA 0 cannot be assigned to some other pin, it will be here only. Okay. So this is the simplified PPS block diagram. Basically you can see RA0 to RC7. So these are the thing inputs, and it will be taking peripheral ABC to peripheral XYZ. Got it? Or this will be kind of output. So RA0 to RC7. So all these will be output. So whichever way you want to connect, we will be seeing. So we have two tables. One is input table and one is output table. And both the tables we will see what are the different functionalities that can be mapped to this particular pins. Okay. So let us do peripheral pin select models. So these are the input selection register table. Okay, so inputs, let's say interrupt 0 PPS. So INT 0, interrupt 0, you can connect it to default pin is RB 0, but you can still connect to your, I will tell you only 40 pin device. Okay, because our target device is 40 pin. So you can connect to any of the pin in port A and port B. Okay, so instead of RB0 using for interrupt 0, you can connect it to port A pin, any of the like RA0, RA1, RA2 kind of thing, or RB0 to RB7, any of the pin you can connect. Similar to that interrupt 1 also, port A or port B you can utilize. Got it? But by default, the pins are RB0 and RB1. So if you want to use the default values, you can come here and utilize them. Got it? Similar to that interrupt 2, you can go RB0, sorry, RB2, or otherwise port A, port B both. Now coming to the fact that timer 0. So timer 0 clock input can be given to RH4 by default. So basically input are actually mentioned in the pin allocation table also. But if you want to have more choices, then you can come here in this table, peripheral pin select module table, and see the exact values. So port A and port B can be mapped to timer 0 clock. Similar to that, timer 1 clock and timer 1 gate, timer 3 clock, timer 3 gate, timer 5 clock, timer 5 gate, timer 2 clock, timer 4 clock, timer 6 clock. All these are having default values. So if you want to use the default like lines, you can utilize them. Otherwise you can map to other port pins. Got it? ADC converter trigger is also there, that you can use RB4. So if RB4 is already used for, let's say, timer 5 gate, okay, what is the problem that you face and you need this particular capabilities? Let us say like timer 5 gate you have used RB4. Now ADC conversion trigger you want to use same RB4, not possible. So for that, either you can use port B or port D. Got it? Now capture compare PWM1 and PWM2, that is mentioned directly to RC2 and RC1. If you want, you can use other pins as well, like B or port B or port C, and port B and port C. Got it? Some other are there like CWG pin. I told you complementary waveform generator. If you know the name, so default is this, and you can have these four are for 40 pin package. So port D, port B, and port D are having capability of those things. Data signal modulator, carrier low, carrier high can be used directly RA3 and RA4. So I'll suggest you try to use the default values always. Okay. And if there is a mismatch, or there is like functionality problem that I am having not able to map properly, then try to use the alternative that is available in the PPS. Okay. DSM source is RA5 default. So this is your default, and this is your 40 pin availabilities. Now UART receive, UART clock, UART receive, to receive, UART to clock. So all these pin can be used for RC6, RC7, and RB6, RB7. Got it? Then MSSP1 clock, MSSP1 data. So those can be used for your RC3 and RC4. Rest other you can still use port B, port C, and port B, port C. So when we will be mapping our particular functionalities in our design, we will be able to see the complete picture in our application design. Okay. So just remember that this thing what I am showing you is your input selection table. Okay. So all of these are input. You cannot see here transmit. Okay. There is only receive. So CLC in configurable logic cells are like CLC in 0, 1, 2, 3. So they are having default values as well as the extended values that you can utilize. Now let us talk about output. So this is my let's say one more still it is input. So CLC 4, 5, 6, 7, you can have these pins. Now let us see the output selection code. Okay. So in output selection, if you see CLC in we saw, now CLC out, if you see CLC out like 8, 7, 6, 5, 4, 3, 2, 1. So for out you have to, you do not have default values, because I told you just now the default values was mapped for inputs, but output you can map it to any other pins. So you have to go ahead with port D for out 8 and 7. Okay. Similarly 5, 4 and 3 you have to go for D and D. But for 6 and 5, you have to go for port C and port C. Okay. Similar to that, ADZ, RDB, and ADZ, RDA, and all these things you can map to respective ports that is given. Got it? Now, the main thing that I wanted to tell you about PSP functionality is SDO or SDA. Okay, so SDO was not given in the pin allocation table that you see. So you can map it to port B or port D. Similarly, SCK and SCL you can map it to port B and port D. So I will be using this port B for your SDO outputs. Okay. Now, whichever is required that I told you. Anyway, SDO and SCK you understood already. We have CMP like comparator models 2 and comparator models 1. We have TX. So TX was not there anywhere. So UR2 TX can be mapped to RB or RD. So we'll be using RB for that. Similar to that, TCK I have already decided port B, so port B we will be using. So only one of the UART will be used because that is more than enough. Otherwise, if you need both of the UARTs to use, you have to utilize, like accordingly. Okay. PWMs you can use. So PWM 3 and 4 can be mapped to PWM 3 to RC and PWM 4 to PWM4 to port C and port PWM3 to port D. Okay, good. Then we have capture compare PWM. So that is pin 2 and 1 that will be mapped to port C and port C both. Okay, similar to that, other functionalities are also there. So good guys, I hope you have understood the complete understanding of pin allocation of this particular device, how you can map a particular pin for your required functionalities. Okay. So if you still have any questions or anything regarding this particular microcontroller, that is PIC18F47Q10, you do let me know your questions in the comment box and I shall be able to answer you out. In our next session, what we will do is we'll try to understand the electrical point of view, like what is the uh, voltage operating range, or like temperature range, or all these things. And after that, we will directly get into the circuit design with different peripherals. All right, thank you so much.